Hi and welcome to Jim's radio shop, where I'm going to be working on this Soundtech preamp. I have no schematic for this guy, and what I determined quite some time ago, I'm going to have to dust off my memory on this, was two Zener diodes located in here had failed. And I've acquired the replacements. These are a little unusual. These are high voltage Zener diodes. Got lots of them, so if I put them in and they blow up, not the end of the world. I was suspicious about this guy here, but he actually tests okay, or so it seems anyway. And there was a burned up resistor in here. The value of it, well, it could not be determined because it's totally blown. So I'm gonna have to look at this and make some deduction as to what resistance should go in here. Don't know how I'm gonna do that. The Zeners I can put back in no problem at all. So that's what we're gonna do. We're gonna put those in. We're gonna come up with some resistance to put in here, and give this guy a go. Now, I think I have the board loose here already. Yeah. Hey! Hey, look at that! So that's where my missing screwdriver's been for about a month. A month or more. Great! This is, by the way, welcome to my favorite screwdriver. This is a sewing machine screwdriver. It came out of my wife's sewing machine. I got my hands on it probably 30 years ago, and man, this has been the greatest screwdriver. I really missed them the last month, but I knew he'd show up sooner or later. So we're just going to put in these Zeners here. Let's take you up in the world. There we go. Whoops, I set everything on. No, I didn't. Here's the two Zeners. And they're going to go right in here. And the numbers are actually written right on the board. So even though I don't have a schematic, at least I have that information to go on. This is a fairly high-end amplifier. It was built probably in the early 90s. It has two vacuum tubes in it because of the popularity of that kind of thing. So it needs to have a high voltage supply, so it makes it a little bit complicated. Okay. Now, I don't want to make a mistake here. The plus end of the diode is indicated, not the banded end. You know what? I can't remember. I can't trust my memory on this, so just... Okay, so some quick research just to remind me. The marked end is the negative end. That should be easy to remember. Now this guy, he's 1N4007. That goes right in here. Don't swing a soldering iron around unless you need it. Something bad may happen. So I can shape the leads a little bit. I'm going to leave these elevated off the board just a wee bit too for cooling. Now if you saw my earlier video on this guy, you would have been surprised, just like me, at what somebody did on this. They put in a component, just like I'm doing, but then they forgot to trim the excess wire off. And put the amp back together. With the excess wire sticking out, and you know what? It caused a short circuit. And I think that short circuit is what blew this. Blew these two diodes. So, having cleared that away, I don't want to get burned, he says, as he gets burned. I'm not sure that's going to do anything. Let's see. It went the wrong way. Crying out loud. Is that a rule about don't hold the soldering iron while you're doing other stuff? There we are. Okay, so that one's in. They left the lead sticking out like that, and it shorted. I have a video of the short circuit occurring. Negative's down here. The band is down there. That's good. So also, if you look at this board, you'll see cut marks here. There's some more. Cut here, cut here. And so what I learned is that this amp went back to the manufacturer about, I don't know, 5 years after it was sold, and it was upgraded. So you see a lot of capacitors got changed on it, and some circuit changes were made. So not only do I not have the original circuit diagram, I don't really know what these changes are all about. But I think it's a safe assumption that the fault was the short circuit from the wire leads. I hope that's the case. Going to make this easy. So this one, negative goes up here. Again, I want to leave this up just a little bit. So I'm not going to make the same mistake. Now, there's quite a few wires here to reconnect. this guy here, this guy here, and these two guys here. I probably photographed this. Photographs are in my playbook, which I'm using to video right now. Okay. Well, this guy obviously goes here. This guy goes here. And these two guys back here. They're going to connect down there. Again, I'm just going to tack them on right now. I did this in such a way that the wires would remain in their right orientation. Sounds like famous last words again. Now these two black ones are both ground wires, but they go to two separate pins. But again, I've left the wires undisturbed and roughly in their right position, so this guy there, and this guy is going there. There we go. Okay, now we're at the difficult part. That's where I have to test this. I got to feed a signal in and listen to the signal coming out, and feed a signal in easy enough. Listening to the signal coming out is a little tricky for me in my shop here. Yes, sirree. Uh-oh. More wires. I gotta check the photograph on this, so give me a moment and I'll be right back. Okay, I did manage to find the photographs that I took and verify the wire connections here so I don't make any mistakes. Now I've gone and put all these wires on. I didn't do anything about the resistor in there. It's okay, I can do a clip lead job on that. Because we need to experiment a bit. I think what I'd like to do about that, I think you're better off with too big a resistor than a small one. Got hot. Sorry, I have my hand right in front of you there. So this missing resistor, I think I will solve it with clip leads, because I can clip here, and that's just as good. Temporarily install a resistor there. Another alternative is to leave it missing. How would that help? Well, if I leave it out, assumably it's blocking current from something, and the worst that happens is less happens than should. If I put it in, I put the wrong size in, too much current flows, something's going to happen here. These are going to burn, this is going to burn, something, I don't know. So if I put a really big resistor in there, if I put any resistor in there and these things burn, then I'll wonder if this resistor was the cause. So you know, it might be wise to do this with the resistor missing. Now that, you know, that resistor is right off of these parts here. I can see the circuit board is quite easy to see here. So it's, the current will flow through one, through the other, and this is a weird arrangement here. Come up here, this jumper feeds it, let's see, here. The missing part won't let it get there. This is still getting, it's not cut right off. I don't know. I think the best thing is to try this with the resistor completely out first. See if these guys stay in. That would clue me to some other kind of problem that might be happening. A short on one of these. You know, another alternative is to bring the B+ power supply up using my external supply. It's a little more of a controlled approach, but and then actually testing this to see if there's some sound coming out of it. That's a bit of a problem for me in my shop right now. I used to have a nice big stereo in here with speakers connected on all, and I took it out in favor of a smaller radio. But now I have nothing to hook a preamp to, or do I? It's a bit of a hassle. Well, even without any load connected, we can go some distance with testing this. So why don't we do that? We're going to spend a lot of time hooking this thing up. I'll need to find out it's going to smoke these two guys anyway. And I will just have wasted a lot of time. I see there's two relays. There's a relay here and a relay here. So maybe if we listen for those to actuate, that might help us know that it's working or not. And what else could happen that would be really bad? Not too much, I don't think. It's not like I took every component off the board and put it back on wrong. Nothing like that. So, and I did operate this thing with these burned parts in it for a while. So all that adds up to, let's plug it in and see what happens. Power is off. My supply, my safety supply. So what I'm going to do here, I have these two light bulbs that I can use when I'm controlling current. This is 100, that's a 40 back there. So I've undone the 100. So I got a 40 watt bulb in series with this guy. It's not much, this is almost no power draw, so it's not going to make much difference. But if there's a big short, we'll know it right away. On-off switch is off. Nothing else matters. actually have my voltmeter at the ready here. In fact, I'm going to hook it up so I'm monitoring the B plus voltage here. I got to pick off a ground point. Right there. And a positive point. I think that's one right there. Looks good enough for me. I can't remember what I did last time. No schematic to work with. So we'll go like that. Okay, I think we're ready. I think we're ready. Can't be too much excitement from this. No panel light. Yeah, there is a panel light. And okay, so we're ready to energize the outlet here. My voltage today is 124, and of course it's a very cool day here outside of Toronto, and nobody's got the air conditioners going. In fact, I'm sure some people are thinking about turning the heat on already. Well, all that's left is to throw the on switch, so let's do that. Here we go. 270, 300, 350, 375. Oh my gosh. 400 and going up. Wow. 430 volts. Wow. No heat in the diodes. Some heat in one of these resistors here. Supply voltage is actually lower than I would have imagined. It's down around 100 volts, so this thing's sucking back some power here. Yeah, we got something really getting hot here. 50. Don't like that. They're getting very hot. No heat in that. A little bit of heat over here. So no heat in this guy, but this guy's warming up a bit. Okay, I can kind of smell the heat coming off that resistor there. Gee, how hot do you want your resistors to get in normal operation? We're way up there at 57, 58. That's like both of these guys here, quite warm. And like I say, we're down at my gosh, this voltage here on the supply has risen to 480 volts. Oh my gosh, doesn't that sound crazy high? 480 volts. It's still going up. Same thing there. Oh my gosh. Nothing there. Nothing there. These parts look like they've been hot before, so maybe that's the normal operating temperature, and why they have two in series is for the wattage problems. Rather than one resistor, they put two in series there. But the diodes are holding in. No heat in them at all. Let's just do a quick scan here and see what else is warming up. It's nicely warm. This guy's cold, so there's nothing happening here. Probably because I haven't put that resistor in yet. Tubes are heating up. A funny colored resistor down there. Oh, I think that was the vacuum tube. I hit there for a moment. You stick your finger into something with 500 volts in it. Not recommended. Okay, so what have we learned here? We learned that there's a pretty heavy current flow down through here, which we might want to 530 volts. I want to see what the voltages are on here. Yikes, 230 there. 475. 484. 530. 489. Well, that doesn't look good. You know, the same voltages on this guy here. So it looks like he's shorted. He's shorted, and this resistor is still missing. And you know, I'm going to guess this is the voltage regulator, and it's not regulating. And that's why we've got this whopper voltage coming out of here. Okay, I think I've seen enough. So I think the next step on this is to pull this part out and check it for proper operation. Okay, let's just do a little safety thing. You think that voltage disappeared off that cap? 200 and dropping rapidly. So I'm going to let this guy just calm down voltage-wise for a moment. And then we're going to remove this guy. So that means I have to disconnect these wires here. My soldering iron's really cooking. Okay, and the ground wire from here. Lift up the board. There's the three there. I have to take those little ground wires off because they're just not quite long enough. Okay. Set the board up. Let's just take a close look at that for a second here. Well, he's got the heat sink soldered in, or glued in. He's glued in the heat sink here with, looks like hot glue, so we can probably melt that out. And we'll just suck the solder off of those guys. We should be able to get this part out pretty easy. Okay, on that, there he is. It's a TL783C. I don't know what that is. Offhand, let's give him the ohm meter test here. Diode test. My diode tester doesn't work. I gotta change the battery in my meter here. Okay, we'll give it the resistance test because I think my meter's still doing that okay. Not sure what to make of any of these readings. I'm getting basically an open circuit on this thing. These things, I think they tend to short out when they fail. Well, it's over 2K in every combination there, so I'm going to read up on this guy a little bit and see what he is and what I should do about him. And thanks for watching, and another continuing saga here with the Soundtech Preamp 1.